that are being conducted, it would be recorded and it would be uploaded into the training door. That is where you can see the videos and the other PPTs that are available. It's free. So if you haven't enrolled yourself to training.info, go ahead and do it. Just these are the steps to enroll it. Go to this website and over there you can see a webinar options, and over there you can see the free 3 days webinar program. That is where you need to sign up and enroll yourself. So you can do it later, not right now, right? So first, I will give a brief introduction about myself. My name is Basil. I work as CTO of a Revel Grid. The company's name is Revel Grid, to which I am a co-founder as well. And yeah, I work in operations, then development, business management, and I also take corporate training for corporates into DevOps and AWS technologies and stuff. And yeah, I mainly focus on migrating the native monolithic applications into cloud. That's what I do at my work, and we help the companies go cloud native. Migrating their monolithic applications into cloud native is what we do as a service for our company. And yeah, this is my LinkedIn profile if anybody want to connect with me, and my contact details. Okay, of course, it's not about me that you want to hear much, but yeah, we will directly jump into the program, right? So before I start, I assume that you all have a little experience into IT, which is kind of required for this program. At least a 1 year experience would suffice into any IT technologies. It would be good enough. So I will just walk you through how does things look like in a company, right? Think about any software company, a retailer, or a cab application provider, or any software company, a startup, or a well-established retailer, or think about any company. Maybe think about the company that you work in. They will have a software application, right, which is the main revenue generator for that company. And it's very important for them to make sure that their customers are happy by giving them frequent updates to their software, right? That's what every company do. Think about the amazon.com or any Uber applications. You would actually find more and more features coming to the software product as the days pass. Think about how Amazon was looking like maybe 5 years before. So that's what a company do. For every software startup company, they will keep on adding more and more features to their software product. Earlier, there was no option for you to become a prime customer at Amazon. Now you have. Or earlier there was no option to make payment using Beam UPI, and now they are being added. So that's what every company should do when they manage a software. Every company should make sure that they keep on adding more and more features to the software so that the customers will love it. And that's kind of mandatory today because you have a lot of competition in the market, right? It's very important. And if you plan to decide or implement a new feature into your software, it's very important that you implement it so quickly because it would run out of the market, right? Think about the Beam UPI being integrated by different people, and maybe after 6 months it would not be relevant. Maybe a new payment method has came into picture which would have almost replaced the new payment method. So what I am trying to do is you work or you make change to your software based on today's industry demand, and it's very important that whatever change that you are working in, they are put together into your production website. That means you make it available to your customers. It's very important, right? You decided that you would start implementing the Beam UPI payment. Your developer would start the work. Maybe as soon as they complete the work, it's very important that you should put that work or make that work available to your customer. Now your customer can make the payment on your website using Beam UPI. So So a lot of change request, I would rather call them the changes, right? Any new feature which you want to add to your software application, or a fix that you want to make to your software. So that's what happens when you try to add a new feature. It's a lot of work for the development team. They do a lot of code modifications and they will deliver their work, right? They will modify the code and finally they will make the code available to the people, the stakeholders, and they will take the code, process it, and do a lot of testing, and finally it would be put into the market and making it available to your customers. So a development team or a team who is working on the software can actually expect a lot of change requests coming from different team. The marketing team who is working for the company, they would assume, okay, let's start implementing a new payment method which came into the market in our system, because there are many customer who is using that payment method. So it's rather we implement this payment method as soon as possible. So these are called change request, the request to make some changes to your software. And there would be a lot of change requests that would keep on coming to the development team, asking them to make some changes. So the change request can come from the marketing team who decided that this new payment method should be implemented. The change request can come from a testing team who tested the software and they identified some problem. Maybe some people are not able to log into your website and that problem need to be fixed. So the testing team would open a change request asking the development team to fix these issues. So when you work in a company, I mean, I hope most of you, if not all of you, are working in a software company. There would be a lot of change requests that would keep on coming to the teams. And in every company, there is a production infrastructure. It's called a production infrastructure, which would actually contain different machines. And these machines are serving your software to the people. That's what these machines will do. The code or the actual software, when in the beginning stage, this is nothing but the plain text code wrote by your development team, right? And there can be different projects that they are working in. There would be one project that take care of the shopping cart software. There could be another project that take care of the payment methods, another project that take care of the beam UPI payments. So there would be different project. One project that would take care of the data analytics, right? For figuring out what your customers need from the previous order history and stuff. So in every company, there would be different software projects, and these projects work together, right? In order to serve the full stack software, these projects work together, and at the end, they are going to run in a set of machines in your company. A set of machines that your company manage in order to serve the software to your customers. And these machines would run your software. Maybe these machines would run your shopping cart software developed by a set of developers, and this machine would run a different component. So there are different software component, one payment component, one analytics component, right? Some database components. So there are different components which would run across these machines. And these are actually the machines which would serve your customers, right? When your customer requested for your website, maybe they will get connected with one machine in your infrastructure, right? I'm just giving you one scenario, right? Just don't assume this is exactly what happens, but just a scenario. So a customer who has requested for your website, they connected to a machine in your infrastructure which is serving or which is responsible for serving the HTTP traffic. So they will serve the website to your customer. They will see the website, and now they try to make a payment or they try to create a new shopping cart. This component might communicate to a different component which takes care of the creation of shopping cart, adding new items to the shopping cart. So any kind of shopping cart operations are managed particularly by this particular software component running on these machines. So what I'm trying to do say is every company maintains such an infrastructure. This infrastructure would contain a number of machines, maybe running different operating system. Windows or Linux, and these machines would run different software component, and they would communicate each other based on the requirement, right? When you try to create a shopping cart, yes, then this software component need to be communicated, because this is the component that can take care of the shopping cart operations. So every company need such a production infrastructure, right? And again, when a developer makes some code change on any project, you don't directly bring those work done by the development team into the production infrastructure directly. It's pretty dangerous. You never do that, because when a developer make a code change, you expect a lot of problems in that. Actually, maybe the new feature the development team have added, maybe it is not working correctly, or maybe when he added this new feature something got broken up, right? A different feature got broken up. So these kind of things would continue to happen in every companies. So it's a real bad idea if you have to bring this software to production. You don't directly bring it here. Before that, you want to do a lot of testing. So I'll just talk about the overall infrastructure overview that a company follows first before we start with our actual CI/CD topics, because these are things that you need to understand. And this infrastructure which I talked about, it's called a production infrastructure, and it's very clear, right? First, you would verify the work done by the development team before you would move those work into production, which is a very critical or a very sensitive infrastructure. You don't want any problem happening to production, or you want to make sure that a software component, if it is getting installed in production, it is secure, right? It is safe, it's bug free, right? So a production infrastructure is pretty well maintained by the people of your company. And like I said, any change the developers make, you won't put them directly into production. There would be different infrastructure the company owns. There would be a testing infrastructure. Maybe it can be the laptop of a developer. First, he will, after making the code change, he want to make sure that this component is working. He will he will run the software component in his laptop, make sure that it's all looking good, or whatever new functions or whatever new code that he added, it's actually working fine. So so once he tested the code in this environment, generally called a testing environment, then the same code is moved into a different environment, generally called a development environment. And yeah, different companies name in it the way how they want it. A development environment would actually look like a production environment. It would contain different machines. It would contain different components running inside these machines. And it is something like a replica of your production, but these machines never serve your customers. This is used only by your internal team, your development team, or your testing team. Every company will have another team who is doing the test job. So for such purpose, this environment is being used. First, you will run the software in this environment. You will maybe try to make a payment using the Beam UPI or whatever work the developer have completed. Just you will literally do a complete testing on your software. Not only the new changes, but a lot other changes also. But I'm not going in so much depth on that. Just understand there are a set of tests that you want to run inside development environment, and if the code is working fine in the development environment, you again want to test the same code in the staging environment, maybe the environment which is sitting just in front of production. Maybe before you want to release your software to the public, to your customers, you want to run a detailed testing in the staging environment, and after that it will go to production. So it's something like a pre-production environment staging is. And finally, you will go to production. Productions contains the machines which are directly interacting with your customers, or in other words, this is the infrastructure serving your software to the customers, a live environment. So which should be taken care very well. Any problem happens here, you don't really care, you fix the problem. I mean, you always try to detect the problem that can possibly happen in this environment. Then you will give the feedback to the development team, telling them that something is not working. We tested this on the development environment, but I'm not able to make a payment using Beam UPI, using the new code change that you have developed. So there is something wrong in it, please look into it. Or sometimes when a developer worked on some problem, maybe something else can break. A developer was trying to add a new payment method into their payment system, and by accident he modified a function which was mandatory. I mean, for implementing the new payment method, it was mandatory for him to modify one function, but actually the function was used by a different payment method, for example credit card, and the change which this guy had made broke the credit card system. Maybe he is not even aware that he broke the credit card system, right? That's why I said whenever a developer makes some code change, there's a very high possibility that new issues are getting introduced, and it's your responsibility as a company. I mean, responsibility is not to figure out who made the problem, it's to figure out the problem and then apply the fix as soon as possible. That's very important, and that is the reason you have this whole setup. First the code will undergo testing in one environment, then later into another, later into pre-production, and after that only it will go to production. This is how it look like. And make sure that you are on mute, right? While you are in the class, make sure you are on mute, please. So just I'm telling you this because I just want to give you a brief idea, those who don't know these things. This is how, these are the different stages the code need to undergo testing, right? Okay, so let's talk about such a company who are getting a lot of change requests, and there are different teams in the companies, right? There is a development team who do the development. I mean, they are the ones who will develop the source code. Source code is nothing but the code which the developers write in order to develop the software. So they are the ones responsible for doing such kind of code modification. When they, and the change requests generally come to them, right? Not mandatorily, but assume whatever change requests that need code modification, those change requests would always come to the development team. For example, implement the new payment method, or give this prime customer option to the customers. So these kind of new feature request that can come to the development team, or sometimes a request can come from the testing team saying that something is not working, please fix it. So it's always the development team who will work on the change request. Different people are part of this team, and after they made the change request, in every company there would be a testing team. They are the one responsible for, or testing team or QA team or whatever name, quality assurance team. They ensure that the quality of the software is maintained. Whatever change the developers are doing, it did not affect your software. The existing status of the software is maintained. The new feature that the developer have added, it's working fine, right? All these things, the QA teams takes care. They will run a lot of testing. Sometimes they do a lot of manual testing. Sometimes they will develop some script that when they run it, it can do the testing. So they do a lot of testing. Whatever work the development team do, QA team will make sure that they are working fine. And sometimes the development team expect a good amount of delay from the QA team, because there are a lot of change requests that would keep on coming. Think about hundreds or 20 or 25 change requests coming into the development team every week. That is the frequency of change requests that are coming to the development team. And yeah, that is true. You expect, when you work for a company, you expect, depends on the size of the software of course, but you expect a good amount of change requests that would keep on coming to your software. It is your responsibility to make sure that these change requests are being worked on, they are being tested, and finally it will go all the way to the production infrastructure. I mean, in other words, you release it to the market. So there are some problems actually when the development team work. There are some conflict. I mean, the reason why CI/CD is mandatory is what I'm talking about right now. Some common problems that every companies are facing. For the development team, their responsibility is to work on the code modification. They will modify the code, they will deliver the code, and the QA team can, right, with necessary environments and stuff. QA team can do the verification of the work done by the development team, and they will finally give feedback to the development team. And generally, it would take time. The feedback can take time because there are a lot of tests that the QA team want to run. Some of them are manual, right? A engineer need to run the test manually. Sometimes there would be a script that the QA team had developed that can do many testing, and again for running the test it need a QA member to run the test, and finally a report would generated and it would be sent back to the development team. And development team generally get the feedback very late from the QA team. Maybe after a week they are getting the feedback about all the change request of the previous week, and by that time the developer may have lose the track. Maybe think about this one developer Tom. He was working on adding the new payment method, and by mistake he broke the credit card system, and he is not aware that it was his change which broke the credit card system. And when he get a feedback, or when the development team get a feedback from the QA team, they have no idea where this problem came from. So identifying the problem would take a big deal, then fixing the problem. So the development team consume a lot of, or spend a lot of time to troubleshoot the problems or fixing the existing problems in the system. The main reason for this is development team get the late feedback from the QA team, but they cannot blame for them because QA team have a lot of work to complete before they can send the feedback, right? Every team has their legitimate concerns, and in every company there's a operation teams. They are the ones who used to take care of the production softwares. So right now I'm talking about the scenario where there was no DevOps, right, where there was no concept of CI/CD. At that point of time, I mean, these were the problems that people used to face. The operation teams are the one responsible for taking care of the production infrastructure, taking care of the staging infrastructure, or any new infrastructure which QA or development team might need for running their testing. It's all done by the operation teams. They take care of such kind of task, and they do a very important job, right? Taking care of the production machines is like, if there is a problem or if there is a customer complaint that are coming, it's the operation team who will take the heat. If a machine is down in production infrastructure and it is affecting your customers, yes, it is again the operation team who take this heat. So they do a very critical job. For them, the main intention is always keep the production infrastructure live and stable. So a development team request to do a release, I mean, whatever work which were completed by the development team want to make sure that this work should go to the market. I mean, you should make this work available to the market. What that means is you will install the production machines with the changes done by your development team. But the operation team, they have this concern. They are not ready to do the release at this point of time, maybe because some campaign is running right now on the website. It is not the right time to do a release, because a release can potentially break the production, and the chances are very high, as per their experience of the operation teams. Yes, the chances are very high that something can go wrong if you bring the work of development team into production infrastructure. So due to these issues, what actually happens is, but they have a legitimate concerns. The operation team has a legitimate concern. They want to hold the release because there's a campaign going on the site. It's a legitimate concern. The problem is All this problem will result in a lot of conflict between the team, and your release process is always affected. Sometimes the QA team need one infrastructure and they are waiting for the operation team to create the infrastructure for them so that they can do some advanced testing. But the operation team is quite busy. It will take some few days for them to create the infrastructure. So your changes are still remain not tested. In other words, they don't become ready to go to production. So these issues will delay your software change management. Even though the developer may have completed their code, but there are a lot of tests that yet to be run because of issues. Some of tests are not completed. The operation team would say, if the tests are not completed, we will not release this. You should first complete. So this would actually result in an ever-ending loop. And the problem is, as the software become more and more complex, these issues would keep on increasing. So actually, the companies needed a solution for this problem, and back in 10 years, nobody was aware of DevOps or CI/CD practices. There were some companies who were doing these practices of CI/CD, which we are yet to discuss, but it was unknown to the people. So there was people needed a better way to manage the software lifecycle management, and it eventually people started talking to each other, right? I mean, the company started conducting conferences, right? They were curious to figure out what the other teams are using, other companies are doing, and finally a new culture have been evolved to manage software change management, that is DevOps. And that is the one major part of DevOps is continuous integration and continuous delivery. So I will talk about that. Give me 2 minutes, guys. Just I need 2 minutes. We will continue in 2 minutes. Okay. Okay, guys. So let's talk about the CI/CD, continuous integration, and the continuous delivery. So yeah, think about a change request that came to the development team. a change request that came to the development team, and a developer will take the request and he will start working on the request. What that means is he will make some code changes, he will add some new functions, remove some functions, modify some existing function. He do the code change, right? Every software are developed from plain text code wrote by the development team. That is the beginning stage of a software, right? So this developer would make the code change, deliver his code change to maybe a storage place. Assume this is a storage, a smart storage, or I would rather call it a source code management tool. Whenever any developer make any code change to their project, assume this is one project that the team is working on, the shopping cart project, and a new change request came in from the marketing team. What the marketing team has requested the development team is, I mean, just I'm saying an example, right? When anybody added some item to the shopping cart, it would show him the different sellers saying the same item and their price, so he can find out which one is cheap and then he can go with that seller or something like that. A new feature that the marketing team want to implement in their software product. So shopping cart is the project that a number of development team is working in. So this developer who is working on this, he will make some code modification and he will update his code modification to this project. And that's what every developer would do. Whenever they make any code change, they will continue to update the code change into the SCM tool. So you can call this SCM tool to be the place where the source code, the plain text code wrote by your development team is what I mean by source code. SCM is the tool which would record all the changes happening to the source code. Whenever a developer modifies some files, SCM will record it. Okay, which developer made these modifications? Which are the lines of code that were modified? What are the exact new lines that he added? Everything would be recorded by the SCM tool. So, in other words, you can call SCM to be a tool which record the complete history of your project. Maybe this project was started 3 years back, right? Along with the company started. At that time, this project have started. It's been 3 years. Whatever change the development team have been making on this particular project, the SCM tool will record them. You can ask the SCM tool when this project was started and what was the first change done by a developer, and in Jan month of 2017, what happened to this project? What were the changes done by different developers in that during that time? So SCM records everything. The complete history of your project is being recorded in SCM. Which files are being modified? Everything. Who modified it? Everything. So assume this information you are making it available for every development team. Assume there are 10 people working on the same project and this information is available for on 10 people. The project became more transparent, right? Which is great. And this is some the transparency and openness is what DevOps need to become succeed, right? To succeed, it's very important. So any team want to track the source code, they can track from here. So anyone can take the code from this place because this is where any developer work on anything. This is the place where they will make the commit. The stakeholders can take the commits from that particular storage SCM tool. And generally this plain text code wrote by a development team, it's actually not in a usable format. Think about shopping cart. Later you are going to install this shopping cart component on a machine and this machine will serve your stakeholders with the shopping cart. Somebody who try to create a shopping cart, somebody try to add item to the shopping cart. This is the machines which would run this software component which the development team is working on this project. When you want to install this software or install this project on this machine, it's not the source code generally that you copy, it would be an executable code. The plain text source code is kind of, it's not in a usable format. First you should compile it, to make it in a machine understandable form. Then this code can depend on a number of dependencies. When a development team writes some code, some functionalities are not available within the programming language. They will get external libraries or external modules from from a different place. They will download the libraries and use those functionalities in their program. What that means is, if you want to run this program, you need these executable files as well. These dependencies are mandatory. So after compiling the code, you would combine the code along with the executable files. Then you would create a new executable file. The executable code is what I would say. Example is the exe file in Windows, right? You, for exe files, you don't care who developed it. You just run it on your machine to install it. Is that right? Or a deb file that can be directly installed on a Linux Debian based operating system. So the companies always prefer to work with the executable file rather than the source code. So for every company, it's a very important stage. Whatever the source code that the people are developing, your different teams are developing, they all are later converted into some executable form so that they can be installed on a machine. I hope it's making sense, right? And these executable files are later installed on a machine, maybe a testing environment where these executable files are tested, validated. Maybe you will even try to create a shopping cart, make sure that it's working, and you will even try to add some item to the shopping cart, make sure that it's working. So you will just do a detailed testing on this executable file on a machine to make sure that the executable files are functioning as it is supposed to. After that, based on what you found, you want to orchestrate these executable files. So think about how many executable file a company will have to manage. Shopping cart is just one project. Like that, how many projects do you expect in a company? There can be maybe tens of them, or 50 or 55 projects can be there. That is part of the main stack software. So each project would result in a executable code, right? Or I would also call it artifact. Artifact is a common name that you would hear when you work as a DevOps engineer. It means nothing but the executable files, right? The final executable file that you create from the source code, it's called an artifact. So how many artifact a company need to manage? A lot of them. And each artifact can have different version, right? Different projects are getting modified very frequently. As more change requests come, development team will make more changes to the software, which would result in a new version of shopping cart. So shopping cart 1.0, shopping cart 1.1, shopping cart 1.2, like that. Each artifact will have a number of versions also. So how many artifacts? Hundreds of them, right? A company need to maintain and manage hundreds of artifacts. So it's very tough if a human have to do all these things, right? So what the companies normally do is they will create some binary repository. It's again a storage place. The SCM repository, which I talked about, this is always used by the development team to track the source code changes. The changes in the plain text code is what SCM would host. This is, I'm talking about a different repository. Once you created the artifacts, then this artifact need to be saved inside one place. And again, some of the artifacts are not yet stable. They need to be tested further. Some of the artifacts are not tested at all. Some of the artifacts are tested, they are working very well, but few more further testing need to be done on them. Some artifacts are ready, tested, looking good, they are ready to go to production. And some of the artifacts which are already in the production. So You need to categorize these things, otherwise it would become very tough. So how do you do this categorization? A person want to manually test the artifact, then move it to the different stable environment. Then if it is also working, it is released. Then this should also be automated. So in short, I would say automation is the key for the whole CI/CD process. Whatever I am discussing, the source code management, the build management, the executable files are created by an automated process. They are saved in this repository again in a automated process. They are classified automatically. If that is the situation in a company, and after that they are tested on a development environment which look like a production environment containing a number of machines running the software components, then assume this deployment is also automated. There are some tool which would take these artifacts, then deploy them, or in other words, run them inside the machines, which machines, based on which machines are supposed to run which software component. The shopping cart component are installed here, payment component is installed here, the analytics component is installed here. So the complete deployment happen into the development environment. Then the testing team want to do some testing. Assume they automated that also. This tool, when it found that these machines are deployed with new changes, again a new automation would begin, which will run all the test suites that you are supposed to run in an automated way. Then a report would be generated based on the testing. Again, it's automated. This report is verified by an automated tool. Then an email is sent to the respective development team if there is a problem, something is not working, an email would be sent to the development team. If it is working, maybe it is time to mark the executable file as kind of stable but need further testing. So this process would happen. In other words, once a developer deliver his code, a new automated process would begin, which would compile the code into compile form, run some unit testing, maybe the new functionality testing would be performed, a report would be generated, report would be verified, and then the code is converted into some executable code. This executable code is copied into a binary repository as a unstable code. Then the executable file is run on a machine. Then if it is working fine, here it would be marked as a comparatively stable. Then again you do a development environment deployment, which would contain a set of machines, and a set of automated tests would automatically begin, which will generate a report. The report would be verified, and the report, if it is looking good, then this artifact is marked to be more stable. Then then it need to undergo further testing in the staging environment and in production, or whatever other environment the company have. If there is a problem, an automated email is sent to the, so a development team, if he is working in such a culture, this is called continuous integration. A development team who is working in such a automated culture, think about this, they don't have any dependency, they don't need to wait for the testing team for 1 week to get the feedback. That's not required. They get the feedback immediately within minutes after they deliver their code into the SCM tool. Making sense, right? And not only that, they don't need to worry about the operation teams taking care of the installation of executable file inside the machines. They can just they can just make the code change, then go to the next change request, right? He don't worry about the code change that he had done. If there is a problem, he know that he will get an email, because a automated CI process would run which would verify the changes of the developer. This is what I call the CI. CD has a different meaning. Actually, it deals with, we talked about only till the building and testing, right? Discussed only about CI CD. This is not what you need. I mean, this is not enough. The code that you marked as stable, this need to undergo series of testing. You want to test it in the staging, want to generate report, do some lot of testing. Again, if it is working fine, then you want to go to production again in an automated way. So this whole process is what comes under CD, continuous delivery. Continuous integration is more like, you can say, the ability of a developer to work without depending on anyone else. Maybe a more understandable definition. That's what CI is. CD is more like it deal the full process, not just CI within the DI. It will also deliver the code to the staging environment, then follow the same process, CI process within staging, then finally deliver the code into production. Again, do some testing on production to verify the changes. So it talk about the complete life cycle of the software. CD, continuous delivery. So that's pretty much about the continuous integration and continuous delivery. That's what my intention. I wanted to give a brief idea what it is. Now it is time for you to begin, right? You can start exploring some tools. I will just introduce some tools to you. Just go through this list and it would be very helpful to you, right? There are different tools available. So if you haven't enroll yourself, please enroll yourself. Then you will get access to the videos and the course materials and everything. And yeah, so that's about me, and this is continuous integration, just an introduction. Continuous delivery. SCM, so we talked about SCM, the place where the development team will make the source code changes, right? They change the source code, put them inside SCM. So there are different tools available for using as SCM: Git, SVN, Perforce, CVS. So if you want to learn some tool, go with Git, which is a more advanced tool being used by many companies today. It has a lot of features. It can track the work done by the development team. Different development team can see the work of others. They can keep a repository within their laptop itself, then deliver this, copy this repository to a remote machines. There are many features that Git has. So those who want to learn SEM, I would suggest Git would be the right tool that you, if you don't know any tools, Git would be the right tool to begin with. The other tools are actually nowadays being migrated to Git. So it can take care of these kind of things, right? I'm not going into any technical or installations or stuff. These are something you can get from Google, but not the concepts. So just focus on the concepts through this webinar till Friday. We will be discussing the main concepts and how do you begin, right? If you want to begin with the build management, there are few tools available. Okay, I did not mention here, there is something called Maven, and there is something called Gradle. But before you start with these tools, these are little advanced tools. You start with Ant. There's a tool called Ant. Otherwise, right, first you need to understand, you need to take some sample Java application. You can download some sample Java application from internet, and you will learn how do you deploy or create a learn these things, how to create a jar file from a Java source code, or how to create a war file from a Java source code, which are nothing but the executable code or artifacts. And this creation process, the artifact creation process, just figure out how you can automate it using Ant. Then after that, after you completed learning Ant, then move on to Maven, right? And Gradle, which are advanced build tools that can do a lot of things that Ant cannot do. So just this is how you are learning on the build management side. Then binary repository, there is something called Nexus, which is a very common binary repository tool. I mean, the place where you would keep the artifacts, right? I told you the company how to manage a lot of artifacts. So how do you manage them? It's through a binary repository, right? They should place the artifacts in one place, or other place based on their stability and stuff. So Nexus allow you to create the repositories, binary repositories, the way you want it. So just start with Nexus. There's also something called Artifactory. That's also a binary repository. So just start learning these tools. So each tools, when you are learning them, whatever concept that we discussed today, it's something that you should keep in mind. Then only you will understand the tools, right? Otherwise it would be difficult to right, compare it with the real time examples. So it's very important for that. The binary repository and release management, there are different tools available. There is Jenkins. It's not exactly a release management tool, but yeah. There is something called Maven. When you learn Maven, also learn about Maven release plugin. There is something called Maven release plugin. I will mention that in the PPT and upload it to the training door. So just I didn't have enough time to prepare the PPT. So I will put these tools names also that you want to start with. Then there are tools like Ansible, which is not exactly a release tool, but yeah, it can be used for doing the releases. Ansible is used along with Jenkins sometimes to do the releases. So release means nothing but the development environment are installed with the executable files, or staging environment are installed with the artifacts. That's what I mean by release. You're actually making your software available to an environment, or whatever work done by the development team. You are deploying them into a working environment where you can see the code and everything. I mean, you can see the software. So that's what I mean by release, right? So these are the software that we can start with when it comes to release management. So this is the pretty overview about the CI/CD. And yeah, connect me on LinkedIn. This is my LinkedIn profile. You can just connect me on LinkedIn, and if you have any message for me, you can email me, right? So this is my contact information, and that's pretty much. And yeah, in case if you want any advanced training, just try it yourself, try all these things yourself, whatever we discussed starting from today. If you need any advanced training, I do provide training on build and release process also, if you are interested. I mean, it's up to you. If you are already working, what I suggest is just try to learn it yourself, right? And today our training or our webinar was all about the CI/CD practices. And tomorrow we have config management, right, which is actually a different topic. It's all come under DevOps. Okay, maybe now you have no idea what is the relationship between CI/CD and DevOps. CI/CD is actually one area that improve the change management of software. And config management, it's all about taking care of the machines. How do you make sure that the configurations of your machines are maintained? Something a little different. So it's again, like I said, it's all about working in a better culture. That's what DevOps is, right? So when you work as a DevOps engineer, what do? The answer is you make sure that your team work in a better culture. You make sure that the CI/CD practices are implemented within your team. The config management practices are implemented in your team. If there are any project which for this it is yet to be implemented, you work towards that. So that's what you do, right? It's actually it's a very good job also, right? Maybe some of you are already working in DevOps, and then you already know what I'm talking about. So that's pretty much. And yeah, I will take your questions. A few questions I got from the chat. So how can we test execution for Python code? You should install Python in a machine and run it. So we are not actually talking about any specific applications. Whatever we discussed applies to all the applications. For example, if you want to run a Python code, first you should have a machine where Python environment is installed. Then you can write a Python program. Then you don't need any building also for Python programs. You need to download the modules, then you can run the program. In case of a PHP project, you should have PHP installed, and in PHP also there are no executable files, right? But if it is Java, you need the executable files, and .NET you need the executable files. So for different programming language, the executable files creation is mandatory. Otherwise, also building is mandatory. Building would actually mean not only the creation of executable file, it could also mean You download everything which are required to run the program. So build has that meaning also. Just build simply does not mean that you take the source code, combine it with the executable or dependencies, create a new executable file. That is not the only meaning. Build could also mean that for a PHP project or a Python project, build process would actually mean that you get all the modules which your program need, put them together so that it can be serve it can serve a application, or it can serve a software. So that is also, so in case of PHP, Python, that is the case. Okay. It will take 3 days. Today is the first day, tomorrow is config management, and day after tomorrow we will be covering containerization. So 3 days course it is. So just yeah, let me take your questions. Mm, I will send recorded video. I had recorded today's video. I will send it to you.
Yeah, hi Prabul, I have some.
Okay. Anyway, what is SC and L? Okay. I could not. SC source code. Yeah. SCME source code management. Okay. I think. Thanks, guys. I think you are answering many questions yourself. Thank you for that. Do we need an Artifactory tool if you are using Docker image? In Docker image, generally what you use is a registry. So it's kind of, you can consider that is something like a Artifactory tool. Uh, that is, Docker registry is what it's called. That's the place where you will keep the Docker images if you are using Docker. So yeah, cool then.
And what's the basic difference between Docker and Docker Swarm?
So you will get the recorded video. What I will do is I'll just upload the video in a Google Drive. If you have access to the training door, I will copy the link over there. You need to explicitly, so open the link, then request for access. And when you request for access, make sure that you are requesting access from the mail ID which I know, right? Unknown mail IDs would be rejected. So make sure that you are requesting the access from a mail ID which I know. Then you would get access to the videos also. You can access the request the access from the training door itself. The link would be pasted there. Our session won't consist of explanation of any tools. I don't think that's what the intention of a webinar. It's all about getting yourself started. The tools training is something that you can do yourself. Search in YouTube, right, for the videos, right? Get started using some tools, install them on a Linux machine that you have. So that's how you would get started. Our intention was just to give you the idea what is CI/CD and what should be your focus on the work when you work as a DevOps engineer. That's what it was. Our webinar would focus on. Yeah, what are the basic tools to start to get? Yeah, that's what I said. Whatever tools that you need for CI/CD, along with the PPT, I will put them. I'll modify this PPT just like I had added for SEM. I would add other tools also. Whatever you need for CI/CD, I would put them. And as we learn the other tools, config management and containerization, I would also mention what are the remaining tools that you need to learn. So along with the PPT, it would be mentioned. Okay. Yeah. So cool then. Prerequisites. Okay. What do you need as the prerequisites? You should have some knowledge on Linux or Windows that you might have already figured. You are going to work a lot on Linux. You want to install Git. It is installed on a Linux machine. You want to, right, you want to do anything, right? Mostly you are going to work a lot on Linux machine. So knowledge on Linux is mandatory. Knowledge on networking concepts is mandatory. You should know how the machines communicate each other, right? You might have already noticed many machines need to communicate each other. So how the machines communicate each other on a network, how the internet is configured, some DNS concept, few networking concept that you need to know. And you should also have some understanding about the software, basic software. So that are the main prerequisites. What is a software, how it communicates to a database, all these things you need to know. So if anybody is interested, I do take training on full DevOps that include prerequisites also. A 2 weeks prerequisites training would be conducted. Then CI/CD training would be conducted. Then config management training would be conducted. Then containerization training would be there. All of them come along with projects. So in case if anybody need my help, you can enroll to my training program also. Consider that as an option. Yeah. Cool then. So we will wind up here. Thank you all for joining, and thank you all for joining your interest in DevOps. Yeah, we will continue tomorrow at the same time. Bye. Same time, same link. Thank you.
Thanks, Vasil.